Alright, hey AP Chemistry. So now I want to put together what we've mentioned in previous videos about how to draw Lewis structures and formal charge and put it together into this quick check. So this one says, draw the Lewis structure for CH3F. Alright, so this is the first time I have more than 2 elements in my structure. So first step is to figure out the total number of valence electrons. So I'm going to just do that quickly on the side. Carbon has 4, and how am I doing this? This is a nicer periodic table, but remember, group numbers tell me the number of valence electrons. So group 1, group 2, group 3, group 4, group 5, da-da-da-da-da. Carbon is in group 4, hydrogen's in group 1, and then fluorine is in group 7. So carbon is 4, there's 3 hydrogens, so 1 times 3, and then 7 electrons for the fluorine. If I add all of those up, I'll get 7 and 7, I'll have 14 electrons. Now, between the 3 of those elements, we got to figure out which one is the central atom. Now, there are going to be 2 things that help me figure that out. It is either the least electronegative element, or it is the one that there is the least of. So, going with the least electronegative element, we know for a fact that fluorine is not going to be the central atom. It is the most electronegative element. So it's not going to be center. We're stuck between C and H now. Now between those two, carbon is slightly less electronegative than hydrogen. Not by a significant amount. But if we didn't know that, there's 1 carbon and 3 hydrogens. So using the kind of the obvious rule of whatever there's the least amount of, that one's going to be the central atom. So it sounds like to me that my central atom is going to be carbon, and then there's going to be 3 hydrogens and a fluorine around it. Now, recap quick, we said that fluorine is not going to be the central atom, and it rarely ever is because it's the most electronegative element. And then hydrogen is not going to be the central atom. First of all, hydrogen only forms 1 bond, so it's not going to be the central atom. And then carbon is going to be the least electronegative. So now I'm going to attach everything to carbon. 1, 2, 3, 4. And again, my shape here is arbitrary. Shapes are going to come up in the next chapter. So I just have 4 things around carbon. I have the 3 hydrogens and the 1 fluorine. And then remember, I have to subtract electrons from my electron bank to make sure that I'm using all of my valence electrons in this structure. So I just used 2, 4, 6. I used 8 electrons to make those 4 bonds, and I have 6 electrons left. Now I got to give my non-central atoms an octet, right? And so I'm doing this without the list of rules on the side of me. I have these rules committed to memory, and they could help you. So now I got to give my non-central atom an octet. Well, 3 of them that are non-central are hydrogen, and hydrogen only needs 2. Only needs 1 bond or 2 electrons. So the hydrogens are good. Remember that. Hydrogen only really requires a duet, not an octet. All right, and now fluorine, right now fluorine only has 1 bond. So that means it has 2 electrons. It needs 6 more, and guess what? We have 6 left. So 1, 2, 3, 4, 5, 6, minus 6 electrons, 0 electrons left. Now, I'm supposed to give my central atom an octet, or if there are any leftover electrons, it goes on the central atom. Well, there's no more leftover electrons, and my central atom already has an octet. The 4 bonds makes it have an octet. There is my Lewis structure for CH3F. Let me try and draw the Lewis structure for SO2 now. Now, I'm going to give you a hint here. I'm going to need double bonds with this, and you'll see that how we do this. So, S has 6 electrons. Each oxygen has 6 electrons, and there's 2 oxygens, so that's 12 electrons, right? So 6 times 2. Now I have 18 electrons here, right? I'm going to attach everything to the central atom. I'm going to tell you that it's sulfur, it's least electronegative, and there's only 1 of it. So SO. I just used 4 electrons to make those bonds. I have 14 electrons left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I used 12 electrons to make those oxygens, which are my non-central atom and octet. That's always your next step quickly, is to give your non-central atoms an octet. And then I have electrons remaining. They go on the central atom. So I'm good there. And then now, do all of my atoms have an octet? my oxygens have octets, but I have to go to my central atom now. It only has 6 electrons. What do I do? Well, if there are no more electrons left, and I still need to give my central atom an octet, you make a multiple bond, which requires me to take a lone pair from oxygen and put it in between the sulfur and the oxygen to make a double bond. Now, why did I choose the left side? That's arbitrary. You could have chosen the right side. It doesn't matter. One or the other, as long as you give that sulfur an octet. And if I want to redraw this structure, I'll have sulfur with a double bond O. There are going to be 2 lone pairs on oxygen, a lone pair on the sulfur, and then 1, 2, 3, 4, 5, 6. This is going to be my structure for SO2. Everybody has an octet. Everybody has an octet. So we're good. You want to have a structure that gives everybody their necessary octet or lack thereof. Okay, now remember, sulfur it could have over an octet, but for right now I want to give it an octet. Now the next question says, determine the formal charge for each atom in COCl2. And I put the equation here nicely. Formal charge is valence electrons minus the number of bonds minus the number of unbonding electrons. So let me do carbon first. Carbon has 4 valence electrons, and that I could use from the periodic table. Minus 1, 2, 3, it has 4 bonds and no electrons. So it's got a 0 formal charge. Let me do this oxygen. I'm going to call this oxygen, oh, there's only one oxygen. I'm going to do this oxygen. Oxygen has 6 valence electrons minus 1, 2 bonds plus 1, 2, 3, 4 electrons. This also has a 0 formal charge. Let me do my 2 chlorines here. Look, notice how the chlorines are the same. So if I do 1 chlorine, it's the same for both, so Cl both. Chlorine has 7 valence electrons minus 1 bond plus 1, 2, 3, 4, 5, 6 unbonded electrons. 7 minus 7, that's 0. That means all formal charges are 0. And if all of the formal charges are 0, that means the overall formal charge for this compound, or overall charge for this compound, is 0. So I know it looks like I did all this work for nothing, but no, this is how you calculate formal charge. You do valence electrons minus bonds plus number of unbonding electrons. And what's nice about this is you really want to have to minimize the formal charge. Like get it as close to 0 or close to having smaller numbers as possible or close to having less as possible. This structure must be pretty stable because it's minimized or has the least amount of formal charge. Now, for the last one, I'm going to kind of quickly do this, but it says, draw the Lewis structure for CO2, all right? And it says, determine the formal charge and the oxidation number of C in both, okay? So I'm going to skip to what this looks like. CO2 looks like this. And you could follow all the steps to figure that out. This is the Lewis structure for CO2, and you're going to figure out that the formal charge of carbon here is 4 minus 4 plus 0. That's also 0. But the oxidation number is going to be a little bit different. And I love this question because it connects to the difference between oxidation number and formal charge. Oxidation number is how many electrons have been moved in this process. Formal charge is if all of the electrons in the bonding were on the original atom, what charge would it have? So if I want to do oxidation number, remember that oxygen has a -2 oxidation number, and there are 2 oxygens, so that's -4. That must mean that the oxidation number of carbon is +4. And remember, this is chapter 19 electrochemistry stuff, or even chapter 4 with redox. So I love this quick check because it connected to what we last learned about oxidation numbers and how it's different than formal charge. Again, formal charge is what would be the charge of this atom if all of the bonding electrons were on that atom. And oxidation number is how many electrons were moved in this process. So it looks like carbon had lost 4 electrons to oxygen in bonding. Okay? So this was a quick check. We drew Lewis structures, we calculated formal charge. It looked like I calculated the formal charge and they were 0, but it's still the same process, okay? So, if you have any questions or concerns about how to draw Lewis structures or calculate formal charge, please let me know. The next videos will move us forward into getting our shapes and our hybridizations.